Welcome back, everybody, to day 17, 16, 17, 18 of Foundations of Programming. I always mess up whenever I skip a day. It's okay. Um, we're gonna start off from where we left off yesterday. Can everybody see my screen right now?
Yes.
Okay, cool. Yeah, so yesterday, the last thing that we covered was binary search, right? Um, we covered binary search. We did the assignment, pretty quickly. Um, Now, after we went through it, what would you say the big O notation for binary search is?
Log in.
Yeah, log of n. Essentially because we were grabbing n, the number of iterations, which was linearly with how big our value was, and we were essentially dividing it by two, right? Where the log of two is coming in. If you guys remember that presentation, so it was log of n. So it was significantly faster than O of n, but not as fast as O of one constant. Really, really good algorithm. But now let's talk about sorting, right? So sorting is another way, is another very common computational task. Um, you, for the most part, won't really necessarily have to really sort things in alphabetical order because you have methods like sort or sorted, right? But there was, let's say there was a specific constraint or a way that you needed something sort that wasn't necessarily alphabetical order. You would want to figure out a way of how to do that. One of the ways that we're going to talk about today is going to be bubble sort. It's not the most effective manner out there, and there's a lot much more better sorting algorithms out there, but it's a very common one. It's typically a very uh, basic standard one that people learn when we first start off. So you get the concept of it, right? Here we have a list of all the different types of sorts that you might encounter. Even if you go through LeetCode, you might see some of these. These might look a little familiar. This is just a small little chart that shows you the different types of sorting that you may encounter, and then the time complexity they might have, right? Notice there's best, average, and worst, because really there's different ways to implement the code, as you guys might have seen the ways that you guys been coding. Um, some of you guys might have more efficient code than others. So the way that you use or the way that you approach some of these sorting methods might actually dictate the your time complexity. But bubble sort is pretty good. It's O of n, right? If you do it right. Well, obviously it can be really bad if it's very inefficient code, right? So uh, this is just a quick chart to give you a reference of all the different types of sorting methods. But we're going to be focusing only on bubble sort. So bubble sort, it gets its name uh, from the very fact that when we're sorting some kind of data structure, we're trying to essentially make it in ascending order, where the left side of the data structure is usually the lower values, and then the right side are the much more higher values, right? So bubbling, as the numbers get higher or get bigger, they want to float to the top or essentially to the right side of the data structure, right? That's where the bubble sort comes into play. Bubble sort is going to require you to do some swapping of variables. Now, this shouldn't be new. I've shown you something very similar to this, right? Essentially, there's two ways that you can approach how to switch the values of two different variables. One, which is the one I don't recommend. It's going to be the temporary value. It's the same thing. It just adds an additional line, and it doesn't look as elegant, right? But essentially, you create a temporary value or a temporary variable to hold the value of one of the items you're trying to switch. So when you switch it, you don't lose it, right? So notice we have um, list, right, of index 1 and 2. We're going to hold the value of whatever is at index 1 and a temporary value, and then we will reassign whatever is at index 1, right? When we reassign it, then we technically lose that value, so we want to save it somewhere else. That's where temp's coming in. So we reassign it to index 2, and then once index 2 has been saved into index 1, then we give index 2 the new value of what temp is, which is the old version of index 1. So this can be accomplished doing the exact same thing here on this code snippet on line 2. You call the two variables that you're trying to switch, and then you reassign them to each other, right? You switch the order of how you assign them. It looks a little bit more elegant than this does, right? So whichever one you take, it's gonna be up to you. There's no right or wrong answer. I'm just giving you two different methods that you can use to approach this algorithm. Right, so as you go through bubble sort, you're going to encounter two different variables that you're going to want to compare which one is greater than the other, right? Obviously, let's say if A is greater than B, you can switch the values of A and B. That way, you essentially put your higher numbers to the right side. Here's a little bit of pseudocode for what it's going to look like when actually doing your bubble sort. You're essentially going to have to iterate through your list. You want to start from the back of the list towards the front, right? Because you want to make sure you get your highest numbers to the right side as soon as possible. And then as the highest numbers are already on the right side, you can start moving down to the left side of the list, right? So you're going to want to iterate from the back of the list towards the front. You're going to start an inner loop with a variable named j from the beginning until I is -1. So I is the outer loop, right? So I is the outer loop, the inner loop will be j. You essentially use this inner loop to do the sorting itself. Finally, as you're inside this inner loop, you're going to compare both values of this nested loop. You're going to say if list j is greater than list j plus 1, you can swap the two values. And then at the very end, you're going to return the sorted list. Let's see. I don't have it open, but it should be in your lesson 12, right? Here is a quick little visual demonstration of what it's going to look like. Here you have a list, right? When it first starts off, it's 7, 6, 4, 3. Obviously, 7 is greater than 6, so you're going to swap 7 with 6. Then you compare 7 with the next one. 7 is obviously greater than 4, so you swap it. 7 is greater than 3, so you swap it. That's the first iteration. The second iteration, you restart again from the front. 6 is greater than 4, so you swap it. 6 is greater than 3, so you swap it. And then finally, the last two numbers that are left is just 4 and 3. Notice after each iteration, by the end of it, one number is already sorted at the very far right, right? So 7 gets sorted the first iteration, 6 gets sorted the second iteration, and the third iteration, the last two numbers are sorted because it's only two numbers to compare. All right, so this is kind of what it should look like as you work through your pseudocode. Here is an example of what your bubble sort should look like, right? Don't look at it real quickly. Don't analyze it too much. But this is what it should look like. You should start some kind of for loop. We're gonna start from the back, right? You're going to move your way to the left. And then you are going to start an inner for loop, and that's what you're going to use to do the comparison of the both values of both I and j, and then you swap one to the other, right? So bubble sort's a little complex until you start working on it. So I'll give you guys about 20 minutes to give it a try, and then we'll come back and see how we do. So time is 5:40. Let's go ahead and come back at 6 p.m. So usually people struggle with this concept. But the thing about data structures and algorithms, patterns, stuff like this, like you need to know the trick because really that's what it is. It's a trick, right? It is a pattern. It's a preset form of instructions that typically work for a large set of problems. Um, which is that's my issue with technical interviews because really, if someone really wanted to, they could memorize almost all these different types of algorithms and stuff and pretty much pass any kind of test. But what that doesn't happen because people hate this. They don't like doing this, which is fair. I don't think this is the sexiest thing, but really it's just a trick. So whenever you guys are going through leak code and stuff, uh, and you find yourself on a problem for more than 30 to 45 minutes and you can't solve it, don't waste your time. Look up the answer. um, because chances are that there is some kind of trick to it to reach the outcome. And if you can't solve it within 30 to 40 minutes, I would say no more than 30 minutes, honestly. You're just wasting time, right? If you didn't solve it the first 30 to 40 minutes, um, it's probably gonna take you 2 or 3 hours, and it's probably gonna be you like um forcing it, right? Uh, hard coding certain things that you don't want to hard code. So at that point, it's better to just step aside from the problem, look up the solution or the type of algorithm to solve that problem, study it, understand it, and then reapproach this problem a different day or reapproach reapproach the same type of problem, but not the same problem that same day, right? Uh, but when learning these things, it's best not to try to like guess how it works, because like I said, it's really a trick, right? There is some kind of trick to it that you have to really understand to get it. So and brings me back to bubble sort. As you mentioned before I started recording, this is really the answer right here on the slides that I demonstrate to you guys. The reason why I showed it to you because I knew it was going to take a little bit longer for you guys to understand it. So I wanted to make sure just look at it, give it a try, and just ensure that you know what's happening, right? And to just break this down from start to finish, uh, we start the outer for loop, right? For I in range. Notice that they get the length of the list, but they subtract one. That way they get, let's say the length, there's like 10 items. We're gonna start at index 9, right? We're gonna start at the very end of this list. We're going to go backwards. That's what the -1 is. And we're going to step over 1, right? So we're going backwards by ones, right? It's really just reverse. You're reversing this for loop. So it'll go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 in the index order. And then the inner for loop for j in range of 0 to I, right? Why do we do it to I? Well, as I mentioned before, bubble sort, as you run through every iteration, one of the numbers should be completely sorted and in its place after each iteration. So with that in mind, by the time that you get to, um, by the time the first iteration is done, there's no reason to touch that last index again, right? So we want to go in range of I. So once we're done with 9, I is going to be 8. So we only want to go up to 8, right? After the second iteration, I is going to be 7. So the inner for loop should only go up to 7. There's no reason to check every other number afterwards past the I because it's been sorted, right? So that's why for J in range, it's from 0 up to whatever I is. That keeps it from going all the way to the right and checking numbers that's no longer needed. And then as we do that, we're essentially checking the numbers and swapping them as needed, right? Um, and it's that simple. Let's go ahead and move forward. You guys did, we're not gonna do the bubble sort count. Take a guess what this is asking for you, right? Let's look at the bubble sort and bubble sort count. And the reason why we're not gonna do it is because really it's the same code, you're just adding 2 extra lines. So bubble sort, you have to write the function that takes in an unordered list of integers and sorts them in ascending order using the bubble sort algorithm. Bubble sort count, it's the same thing. The only difference is uh, you're going to count the number of comparisons and the number of exchanges made while sorting a list and return a tuple of the two values. So realistically, you're just creating 2 different variables. Every single time you make a comparison, you update the comparison variable. When you actually do a swap, you update the swap variable, and then you return that at the end. So if you complete a bubble sort count is the same thing. So we're not going to waste time on that. We're going to keep moving forward. We're going towards recursion, but that's really the only difference between bubble sort count and bubble sort. These 2 problems, just really practicing with the variables to understand what's happening. That's it. All right, recursion. Who here has done recursion before? I think Daniel. I think I seen Daniel do it, right? Anyone here, no, besides Daniel, understand recursion?
Understand might be a stretch.
All right. So recursion is really just the act of a function calling itself. All right, so um, we know that functions can call other functions. We've seen that. Uh, to a prime example really is like using like the dot sort method. That is a function. It is a function of in a class, but still a function, right? The functionality of it, it's a function, and we've used that inside of other functions. So we know functions can call other functions, but a function can also call itself, right? So the same function that you're defining, it can call itself again, and that is known as recursion, right? Uh, Really, the best way to understand recursion is uh, thinking about the movie Inception. Have you guys seen Inception, or at least have an idea of what Inception is? All right, so it's like a movie where they're essentially diving through dreams, and then within the dream, they're diving into other people's dreams and diving deeper, right? It's a little weird. If you've never seen Inception, you've probably seen the more modern version of the same concept. If you've seen Rick and Morty, there's a dream where they're going into people's dreams. Um, it's like a Freddy Krueger bit. If you guys ever seen that episode, I'm not gonna say his name because it's not, a nice name, or the guy, whatever his name is. But it's really just going inside of itself, right? That's really what recursion is. Recursion needs two things to work. One is going to be the base case, right? This is where the recursive function stops, right? Think of it as almost like a condition. The base case really is like setting a condition, like a while loop, right? When you set a while loop, you'll say like while true, or you'll say while something is less than or greater than something else, or while something doesn't equal something. Uh, I want you to run this. The base case has a similar functionality, but not exactly. Really, it's just the condition that the recursive call is has, so it knows when to stop calling itself, right? Sometimes you can have more than one base case, and you'll see a small example that's there. The second thing the a recursive function needs is the recursive call, right? This is the line where the function itself is calling the itself, right? Maybe if you're new to recursion, this might seem a little weird to understand. We'll see some code snippets and give you a better understanding, right? So, what was the two things that recursion needs?
A base
A
case and
base
to
case.
call itself.
Right, the base case and the recursion call, or to call itself, right? Correct. All right, so here is an example. I need to remove this one. Factorial one, I feel like it's um not the best example to teach recursion right off the bat, but I mean it works perfectly with recursion, but I feel like if you don't know about factorial, it can be confusing. But here we have a function called factorial that takes in a num. The base case is set here where we say if num is equal to 0, we return 1, else, and then we follow it with the recursion call. Notice that we're returning the number that's being passed in multiplied by the recursive call. So it's calling factorial within itself. So although this is a definition, the definition itself is literally calling the function that we're in the middle of defining. So it's calling itself. Notice that num is being subtracted by 1. And what this does, it ensures that at some point, our recursive call is going to meet this base case, right? So what happened if we pass in, if we call the recursive call, like right here, factorial, and we just pass in num, and that's it. Well, every time that factorial runs, num is going to stay the same, right? So this function will keep calling itself over and over again. And num, because at no point, if we don't add the -1, num never changes. So because num never changes, the base case never happens, right? Num is never able to reach the number of 0 and stop the recursion call. because it never changes, it's going to keep running line 5 every single time it calls this function, ending up with what we call a stack overflow, right? Which really is just a infinite loop, right? A stack overflow um, is, I'll explain it a little bit. It's can be a little tricky to understand, but we'll talk about a stack overflow in a bit. But essentially, it can't call itself anymore. It's ran out of space, or I guess memory in a sense, to keep calling itself. Like it no longer has the ability of like, yo, chill out. I got no more room to work with. I can't keep calling this function. That's it. I've hit my limit. It's pretty much what a stack overflow is, right? But I'll show you right now a much more better example of how that works. Um, I don't know why we have this. This slide is not really anything major, but notice what happens if line 2 doesn't happen. If num does not equal to 0, what happens? It's going to default to the else case, right? Well, if we don't put else, will it still run this? Yes. Um, it is very, very simple. I know most of you guys already know this. I don't know why I have this slide still. I should have removed it a long time ago. But essentially, this is just showing you that you don't always have to put an else statement here, because by default, if this if statement doesn't run, obviously the next thing that's going to happen is whatever's going to be on line 4. So the else statement is really just redundant to put it here. That's all this slide is saying.
Is one preferred over the other?
No, it's just, I don't know. I don't know why it's there. I've been meaning to remove the slides.
It definitely looks cleaner without the else, I think, but I also like
It
the else for my own personal mental understanding sometimes.
Right. So it's helpful, especially when you first start off.
Yeah.
But as you start coding more, you don't really need it. It's just an extra line that you can get rid of. But it's the same thing, right? Obviously, if num does not equal 0, it's gonna run the else statement here. Same concept. If num does not equal 0, we'll never run line 3, and we're just gonna go to line 4. So same, different, but still same, right? But all right. Here is your recursion intro.py. So before we go into this assignment, let's talk about recursion. Actually, this should be the next slide. I don't know why these are like this. But let's talk about what is actually happening with recursion, so we understand what's going on. So I'm gonna have a function called count. Yeah, I'll say count up. This is going to be one of the examples that you're going to be given for the practice assignment, but it's helpful to really just use it as a demonstration. All right, so we have a function called count up that's going to take in a parameter called num. Actually, it does not say count up, it say count down. I feel like it's better. Now, what this needs to do is it needs to print out the num, right? And if it's supposed to print out num, and every single time that we print out num, we need to subtract from num and then print out the new version, right? To mimic the countdown process. 5, 4, 3, 2, 1. So our base case in this scenario, what do you think should happen? What should our base case be if I want this recursive call to stop running after I'm done counting down?
Have a target value set, and then once it reaches your target value, return, like just have a return out of it.
Yeah, I'm gonna say if num is equal to 0, I'm going to return. Right, so if I'm done counting, I say 5, 4, 3, 2, 1, and I've already counted, then I don't need to keep running this function. So my base case here is going to be the moment that num is equal to 0, I want to return. But when we first run this function, num is going to equal an actual number. It's going to equal 5. So I want to print. I want to say print num. I'm not the best at recursion, so bear with me. I want to print num, and then I want to say count down num minus 4. I'm
You're
sorry,
gonna
not
want
4.
num minus
Minus 1.
1.
Num minus 1. I don't know why I said minus 4. Yeah, I'm gonna say num minus 1. Right. So it looks a little weird. Bear with me. So I'm gonna call this. The first time I call this, I'm gonna say countdown, and I'm passing 5 in here. Right. It's going to run this. It's going to read the line. If num is equal to 0, return. Well, num right now, the first time I call this function, it's going to equal to 5. So it's not going to return anything. But on line 3, I have print num. So it's going to print out 5. Right. It's going to be my print statements or my console. Right. It's my console right here. So countdown is going to run. Num obviously does not equal 0. It's right now as it stands is equal to 5. We print out 5. And then the next line in this function is to run countdown again. So usually what's happening in your computer, you have what we call a stack, right? Think of it as like a cylinder, right? Like a big box maybe, right? When a function runs, what happens is this function gets added to the stack, right? Pretty much, it's almost like a queue, right? You guys ever open up Steam? Who has Steam here? You guys have Steam? You guys ever like open up Steam and it starts to update every single freaking game you have on your computer and you're like, yo, relax, dude. I don't need everything downloaded or updated right now, right? And there's a queue of everything being updated and there's an order. It's kind of like that, right? When you run your code and it gets to a function, it's gonna start a queue or it's gonna have a stack of the functions that are running, right? This is the current function that is open and running right now in the stack, right? That's what happens the moment I run countdown 5. But the base case is only going to stop running this function when num is equal to 0. But because num is equal to 5, we print out 5, and then we say count down num1. We're calling the function again. The initial function, the first one we called, does not close. It stays open, right? Because it never finished running, right? This is a recursive call. So what happens is it runs another function, but this time we say num minus 1. So when it runs countdown again, it keeps the first function that we ran open and it opens up a second one in progress. But the first one that we created in our stack is still open. It's an open ticket, right? It's an open function. It never finished. It's still going because within itself, it ran another function. And the function can't stop until everything inside of its code is done running. So what happens is that recursive call, it adds another function to the stack, right? And it quite literally looks something very simple like this, like pancakes in a sense, right? So this runs, countdown is 4, so it goes to the code. If num is equal to 0, return. Well, it's equal to 4, so it's not going to return. It's going to print out num. So in our console, we see 4. Right? And then we, once again, say countdown num minus 1. It opens up another countdown function. Right? Countdown 5 is still open. Countdown 4 is still open. And now it just opened up a third function. So what happens is, this one opens up and gets added to the stack. But this one is num minus 1, so this is equal to 3. And the stack, although it has 2 functions open, that second function started a third one, right? And this is quite literally what our stack looks like, right? So countdown of 3 keeps running. Is it equal to 0? No, so it's not going to return. It's going to print out 3. And then it's going to call another function again. It's going to run the recursive call. It's going to subtract 1 out of the num. So now it's going to be countdown of 2. We added another function call to our stack. This is going to print out 2 because it's not equal to 0. So it's going to ignore the if statement. It's going to print out 2. And it's going to call another function. This is going to equal to 1. It's going to print out 1. We once again get another function. So that it runs countdown 1. If num is equal to 0, return. Well, it's not equal to 0 just yet. So it's going to print out 1. It does that. And then it's going to run another countdown function. This time, it's going to subtract 1 out of num. So it's going to say countdown, and it's going to pass in 0. And now, and only now, does this function meet the base case. So it's going to say if num is equal to 0, I want to return. So now, this last function that got called, that's currently in our stack, I never added it. Jesus. This function right here, countdown 0, is going to close up. It's done. It's going to return, right? It's going to come out. Right? It's going to come out and it's going to close up shop. All right, so this one closes up. It's going to come down to countdown 1. This one's finally done, so this is going to close up. I'm just going to go ahead and just do all these. But essentially, it's going to be a constant chain of every single function call. Now that the last one is done, every single one of them is done, is able to close. Right, so all of these close down one by one. And the stacks inside of our stack are removed. Right, and we were able to successfully print out 5, 4, 3, 2, 1 by just running this function once with 4 lines of code. Right, now this is a very simple method of using recursion, but hopefully this gives you a visual representation of what's happening when a recursive call runs. Right, and then I want you to keep a look at here at this piece of code. Right, not piece of code. Look at this box here. As I mentioned to you before, this is what our call stack looks like. Now, what happens if we don't set this base case? As you have already noticed, every single time it runs the recursive call, it's adding a stack, right, over and over again. And quite literally, it's going to run to a point like this, where there's no more room for our stack to have a recursive call. And then it's going to spill, and it's going to return a stack overflow error. Right? because our stack is overflowing. There's too many recursive calls opened up that have not been closed out, and we can no longer keep calling these functions, right? And yes, this is quite literally where the website Stack Overflow gets its name, right? From this error, the Stack Overflow. Does anybody have any questions of how recursion works? Nobody. Everyone's got it. That's it. We good. Okay. So with that said, let's look at recursion intro.py. Oh no, did I redo it?
Mm-hmm.
No. All right, never mind. Don't look at it. You guys look at it, not me.
Yeah.
Here it is. Here's the readme. My bad. I'm on my other computer, so I opened up last FOP sessions because I haven't copied the repo, so I might have a couple of these already done. So here you have 3 assignments to do for recursion. You're gonna write a recursive function called countdown. All right, I just explained to you, so I want you to do it in code. Don't look at our example and just try to imitate it. Right, that takes a positive integer parameter and returns a string that counts down from that number to 1. Now, I want you to notice, it is a little bit different than what I used as an example. I was printing it out in my console every single step. You're not going to do that. You're going to format a string, right? So you're going to return a string that has 5, 4, 3, 2, 1 all in one string to mimic that countdown, right? So if 5 is passed to the function, it should return the string of 5, 4, 3, 2, 1, all in one line. You can use string concatenation in your recursive function to build up the return value. And then you're going to do the opposite. Instead of count down, you're going to do count up, right? That's going to be the second assignment. And the third one is going to be a function called sum count up that takes an integer parameter and returns the sum of all the integers from 1 to that number. Right? For example, the function is passed the value 5, then it should return 15 because 1 plus 2 plus 3 plus 4 plus 5 is 15. Right? Do I have any questions on these 3 little mini assignments for recursion? Okay. Time is gonna be about 6:30 in like the next couple seconds. So I want you to take your first 10-minute breaks of the night. And then you're going to work on this until 7. We'll come back, we'll do an example, and then we'll go into recursive mode. And then we will move on to regex for today. So we'll get into our last lesson today, and we'll probably finish it tomorrow. Do I have any questions? Awesome. Give recursion intro a try. I will see you guys in 30 minutes. All right, let's go ahead and get back to it. So before we went on break, I give you guys the assignments to work on, which was the recursive intro.py. Does anybody want to demonstrate all 3 of them?
I can do it.
All right, Nick, let's see it. I really expected Daniel this time. How I thought Daniel would have it.
He might not be back yet.
Maybe.
Normally he puts his camera on. Okay. Let me know when y'all can see my screen.
We see it.
Okay, the first one was to use recursion to form a countdown. The function, you pass an integer into it and it would count down from there, printed to the screen. Let me do this. So to demonstrate the first one, I put 20 in there, it goes 20, 19, 18, 17, so on and so forth to 1. So what it does is it's got a base case. If num is equal to 1, it just returns a 1 as a string. Else, or I guess outside that if statement, so if that if statement doesn't execute, it returns the string of num plus a space plus countdown of num minus 1. And so just like you demonstrated with the stack example, it won't actually finish this call, the first call of countdown, until it gets an answer about this one, and so on and so forth, all the way until it gets to 1. It concatenates that all into one big string and prints it to the screen. Or I guess it doesn't print it. It's because I told it to print down here.
Right.
Then for the next one, exact same concept, except in the opposite direction. So the function looks identical. It takes a integer as its argument. It has a base case of if num is equal to 1, it returns the string of 1. The only difference is down here in the I guess the non-base case example, the return statement. It all I did was reverse the so in this one up here, the num was first plus a space plus the recursion call. Now it's the recursion call plus a space plus the num because you need them in the opposite order in order to count up. Oh, and also the num's still minus 1. So if you run it, as you see, 1, 2, all the way up to 20. And then for the third example, we had to multiply without using multiplication, which at first was kind of blowing my mind.
We have to
Oh
add.
no, never mind. My bad.
You went
This
ahead.
is
You did the next one.
Yeah, I was working on that one. This is the sum of all the integers. And so once again, function takes an integer. The base case is if the integer that's passed to it is a 1, you just return a 1, because that's everything from 1 to 1 added together. The non-base case, the recursive call, is you return a call of the function of the num minus 1 plus num. And so just like with all these other recursive functions, it starts working on this math, puts it on hold, it runs the next iteration of this, coming back through the program all the way until it hits 1. And so if you tell it, for example, some count up of 5, you get 15, just like the example shows. Or if you could do, I don't know, I just started with 3 because that was quick and easy in my mind. That should be 6. Yep, 6.
Good stuff. Good stuff. All right. Thank you very much for your explanation, Nick. Really appreciate it. That's exactly what I expected. Let's go ahead and move on with the class. We're almost done with this lesson. Here we have a very random slide, introducing you to the Python tutor. All right, so if you feel like you struggled with really understanding what was happening here, you can visit Python tutor, not tutorial, with Python tutor. Yeah, you can visit Python tutor. It'll look like this. It has a lot of ads, so maybe get an ad blocker. But you're gonna start this with Python, and it should bring you to something similar to this. Oh, where'd the ads go? What the heck? Okay, cool. Last time I tried, there's a bunch of ads. But essentially what this is gonna do is gonna allow you to visualize your code, right? And tells you exactly what happens at each step. So we can say something like define count up, and it takes in num. And then we can say if num is equal to, I like countdown, it confuses me less. If countdown is equal to 0, return else we're going to count down. Okay, print num minus 1. Let's see how this works. Okay. So here's my function, right? Maybe this wasn't the best way of doing it. Okay, let me try something else that has more steps. Let's go to define check list. And this takes in a list of nums for, I'm just gonna make it to hard coded it. We're say list of nums is equal to 1, 2, 3, 4, 5 for num and list of nums print nums times 2. Very simple lines of code. Nums is not, oh, my bad. Where did I fix it? To the back. There we go. So in this Python tutor, what you can do is there's something that really confuses you. If you don't understand what's happening in the line, let's say bubble sort. Bubble sort really just, you couldn't understand the concept or you couldn't wrap your head around it. What you can do is you can come here and you can put a piece of code. And what this will do is it's gonna run you line by line as it's execute, right? Here it tells you the line that just executed and then next line to execute. And you'll take it a step at a time, right? So it executed this list of nums, right? That's the first line that happened. And you can see here what happened was that it created a list from index 0, 1, 2, 3, 4, and here's the variables or the values assigned to those indexes. And then the next step is going to be to iterate with a for loop. So you see here that we grab num is going to be to 1. That's the first item. And then multiplies it by 2. Here you see the print output. And you can see how like this is going to go back and forth through the iteration. And it tells you what num is at every iteration. And so on and so forth. So you can quite literally take this a step at a time and see what is happening in your code to really figure out what's happened, right? Because sometimes it can be very difficult when you have a bunch of different codes, values, variables, naming conventions of all types. You might struggle to understand what is your code actually doing, or what is whatever I'm trying to teach you or somebody else trying to teach you, what is everything happening there. So check out Python Tutor if you struggle with stuff like that. It'll break it down line by line. It's something similar to, I'm sure you've all done it. You put a piece of code in ChatGPT and you're like, explain to me what this code is doing, like I'm dumb. It's trying to explain to you line by line, but it doesn't do the best. So this is a way of doing it that can give you a different perspective. So check out Python Tutor if you think this is helpful. Here are the ads starting to pop up. I knew they were coming. This is the only downside to the website is the ads. So maybe get like an ad blocker if you don't want to see all these ads. But it's okay. The next one, and I believe this should be the last assignment for recursion. Oh no, we have a couple more. The last one's gonna be recursive mode, or the next one's recursive mode. So this one is a little bit like the one that we just did right now, but what you have to do is multiply instead of add, right? So you're going to make a function that takes 2 positive integers as parameters and returns the product of those 2 numbers, right? For example, if we are trying to multiply 7 times 4, instead of actually running the multiplication, we're going to use recursion to do the actual math for it without directly multiplying, if that makes sense. Because it's really multiplying 7 times 4 is just 7 added together 4 times, right? So you're going to break down what multiplication is into a recursive call using addition to reach the same output that this would give you, right? So give it a try. We'll take about 10 minutes on this, and then we'll come back. We'll get a demo, and then we'll move on. I'll see you guys in a bit.
All right, so initially I'll have where you can pass in 2 integers, and then I have a total counter, which I reset to 0 anytime that you call the function initially. If the second integer that you pass in is equal to 0, then it'll print the total and then it'll return out of the function. Other than that, it's just going to be the total function adding the first integer to itself over and over again. And then how we get it to eventually get that base case to be a thing is that we decrease the second integer that you pass in by 1 every time. So that way you just keep adding the first integer over and over again the same amount of times as the second integer that you pass in. So we have 7 times 4 here. 7 times 4 is 28. If you want, we can do, so you can see it works both ways. We can do 4 times 7. You also get 28.
Awesome. Good stuff. Pretty straightforward. I like it. Yeah, the total is nice. It's almost like a counter. No one said you can't use other arguments, right? That you only need one base case and one recursive call. Like if you can set up other base cases as well, you can use the counters to keep track of your values. That's absolutely okay and encouraged. All right, I think we're about to go into the last part of recursion before we close up lesson 12 and move into lesson 13, our final lesson. So it's often that the case that a recursive function will need extra parameters, right? Such as a counter to keep track of which subproblem the function is currently working on, right? This is essentially something very similar to what Daniel did as well, right? He passed in an additional parameter, all right? And here is how that would work, having that additional parameter. It said a POS, I believe its position is equal to 0 as a default, but he updates it as well, right? A position, oh my God, my accent's coming out, Lord. A position, there we go, is equal to the length of string, then we return an empty string, right? But what's really notable here is just the fact that you're able to pass in, default parameters. You're able to pass in a counter. You can add additional base cases, and that's okay. We're gonna do one last problem. List max and is decreasing dot pi, and that's gonna conclude our recursion. Actually, let me pull them up real quick. Let me pause. I want to make sure the limit is worth the squeeze. Yeah, I think so. Let's try is decreasing and list max. Tom is 725. So, what we'll do is we'll work on list max, and it's decreasing from now until 8. Right at 7:50, I want you guys to take your 10-minute break. And then go on break, and we'll come back, and then we'll go through these exercises. And then we'll reconvene then. I will see you guys in a bit. Okay.
All right, so is decreasing. So basically, you have a list, a holdover value. If the list is empty, then we're going to return true because it got through all test cases. If the holdover value is none, which I have it preset to none, it's going to pop the last value in that list and then assign it to the holdover value. Then it's going to pop the next to last value in the list and assign it to temporary. If holdover is less than temporary, because if it's decreasing, the very last number should be the lowest number. Then holdover will then equal temporary. So that way we can just keep moving down the line one by one. And then we'll pass in is decreasing list with the new holdover value. And then it just keeps going through and through. And if at any point holdover value is greater than temporary, then it's going to return false. So I have 2 lists here. The first one is true, the second one is false. And then I put for list 2, this last one is going to be the one that triggers the false. So that way you can see that it gets through the entire thing. So there it returns false. And if we change this to list 1, let me clear the terminal so that you guys can see it all. It's going to return true.
Nice. Good job, Daniel. Kevin?
Alrighty, let's do it. I can share screen.
Yeah.
Okay. One moment, though. So, right here, can y'all see my screen is, hold on, it should be loading up now. Got me?
Okay. Yes, sir.
Mm-hmm.
So, here we are. I did list max. So basically what it's doing, I have a base case right here. If len num list equals 1, then just return just return just that single number. So that means that there's only one item inside this list. It's just going to return it. If not, this is where we actually get to like where it's doing the recursive. We have the largest variable that's set up right here, and in here is calling the recursive function again, and I'm passing it num list, which is starting at the first index, and then just slicing through the list. And for each time like it goes through the list, it's just comparing it to like the first to the very first number within or the 0 index of that list. So I have 3 numbers down here: 101, 65. Basically, it's taking it right down here. This right here is passing in like 101 and 65 into this function, and then right here, after it goes through its recursive calls, it's going to compare it to the num list 0, and that is the 1 right here. So it's going to basically compare 101 to the number 1. It's going to say, hey, 101 is in fact greater. It's just going to return the largest, and now this will be like the number that will turn back after the function ends. If not, it'll just return the number list 0 again. But I don't really think I don't, like, it was kind of breaking on me. I don't think I need this though, this last part right here. But if you run it right here, it does in fact return like 101. Do you see it on the left side of my screen?
The right side, yes.
Your right side, sorry. So it
It's
does return
okay.
it. If I do just 101, 2, and then 1000, I do it again, returns 1000.
Okay. Yeah, good stuff.
Yep.
Awesome.
Thank you.
Thank you, Kevin, for your demonstration. All right. That is all of lesson 12, searching, sorting, and recursion. We have one last official class, which is going to be Python regex and ASCII values. To be fair, the ASCII values is like a 10-minute class. But it's really just talking about ASCII values and what they are, especially if you're like new to technology and not familiar with computers in general. The biggest thing for tomorrow is just learning how to use regex. Regex, which is short for regular expressions. We'll talk more about it tomorrow, but it's a very, very powerful tool. You're gonna need it for working with your backend. When you guys get into the immersive program, regex is going to allow you to essentially, have like password validation as well as email validation. So whenever a user tries to create an account with your application, they're not adding something crazy, um, you know, adding inputs or like lack of input. So you're able to like use regex to format a pattern to ensure they put minimum of like 12 to 16 characters and like one special character and stuff like that. You're all familiar with making accounts. So we'll talk about regex tomorrow, and that's gonna be the last official class for the foundation programming. Let me go and stop the recording now.